Okay guys, so we're going to talk about the rational functions. We're going to go back to them and talk about the graphs of them and what they look like, what are their parts, and all that other good stuff. Okay, so what you're going to learn is how to find the vertical asymptotes of a rational function, how to find the horizontal asymptotes of a rational function, how to graph a rational function, and how to find the domain of a rational function. Okay, so domain, you may have, well, I know you've heard this at least in the 9th grade, and it is the set of x values for a function. And I'll show you what I mean when we get to that. The range is the set of y values. An asymptote is where the graph approaches but never crosses. And I'm going to show you what I mean by that. There are two types of asymptote. Vertical asymptotes are asymptotes that are on the x-axis and stand straight up. I won't say on, but go through. And I'm going to show you. Here's an example. Let's say I have an asymptote at x equals 4. Then I would go to the x-axis, go to 4, and then I would draw a dotted line through that and say this is my asymptote at x equals 4. And that's called a vertical asymptote. And the way you can remember it, vertical means to stand straight up. Stand straight up, like you're a vertical being. All right, I'm gonna wait a few seconds and I'm gonna clear the screen. Make sure you write these words down, guys, in your book creator. Please write these vocab words down because you know you can use them for a test and you can know what they mean so you can find your answers to your questions. All right, so now I'm going to talk about horizontal asymptotes. These are asymptotes that crosses through the y-axis. Okay, they're asymptotes that crosses through the y-axis. And here's what I mean by that. It's going to be, let's say I have a horizontal asymptote at y equals 7. So I draw a graph. And I go to 7 on the graph. So I put a dot here. And we're going to be horizontal. And the way you can remember this is the sun sits on the horizon. So horizontal means to run from left to right. And here we would say this is a horizontal asymptote at y equals 7. Okay? So go ahead and take a second, write that down. You can pause it if you need to write it down or rewind back. But I'm going to go ahead and erase. You can always go back and pause, guys. So a hole is just that. It's a hole. Look at me spelling it wrong. Hold on. It's a hole in the graph. And here's how you identify a hole. So what happens is you have some kind of polynomial in the numerator. And then let's say you factor down your denominator. And you see how we have x plus 2 in both the numerator and the denominator. So what that is saying is if I go to -2, there's going to be a hole in the graph right there, but the graph might continue on in other directions. So it's just telling you the graph doesn't exist in that spot, and we're going to carry on in another direction. And that's normally if the factor's on the top and the factor's on the bottom, then that graph has a hole in it. Okay? All right, so let's talk about something else that's important. So now, we're dealing with a rational function. How do we identify if my vertical asymptotes and my horizontal asymptotes and my vertical asymptotes? So the vertical asymptotes are easy because we've already been doing this. You just take the denominator of the rational expression and set it equal to 0. And that's how you find where your vertical asymptotes are going to be. For an example, let's say I have this rational expression here. And then I have, so to find the vertical asymptote, the denominator is x plus 2. I said this equal to 0. This is just like finding what the extraneous solutions are going to be. And we've talked about this in class. So you're just finding what makes the denominator equal 0. So you would say the vertical asymptote is at x equals negative 2. And so on the graph, you would go to negative 2, put a dot there, and then you would draw a dotted line. And we would say x equals negative 2, and that's my VA, my vertical asymptote. So my graph is not going to cross over this line. It's not going to touch this line. It's going to get very, very close to it, but not touch it or cross over it. And I'm going to show you a graph, what that looks like. So now what happens when we talk about horizontal asymptote? So there are 3 rules, and make sure you just have these rules. I did put them in Book Creator for you already. Just make sure you can understand these rules and you can use them for your test. It says if the highest exponent in the numerator is larger than the highest exponent in the denominator, then there is no horizontal asymptote. So I just did top exponent is greater than bottom exponent. So let's look at this example that I just gave. So here, my top exponent is greater than my highest exponent in my numerator, which is 1. So the top exponent is 3, and it's greater than the bottom exponent, the highest bottom exponent, which is 1. So that means my horizontal asymptote is none. We don't have any. So I won't have a dotted line like this on that graph. So the next question would be, the next one says if the highest exponent in the numerator is smaller than the highest exponent in the denominator, then the horizontal asymptote is 0. So I'm going to rewrite this and show you exactly what that means. It says if the highest exponent in the numerator, so let's say I make this 5, is smaller than the highest exponent in the denominator, let's say if I make that 3, then the horizontal asymptote is 0. So in this case, well, y equals 0. So in this case, hold on, I messed up. This one should be smaller. This should be 3, and this one should be 5. So the highest exponent in the numerator is smaller than the highest exponent in the denominator. So let me show you. So we're just going to simply compare exponents again. Top exponent, bottom exponent. So the top exponent is less than the bottom exponent because 3 is less than, it's less than 5. And the way you remember less than, it looks like an L. So 3 is less than 5, so the HA is at y equals 0. So graphically, what does that mean? If y equals 0, that means the horizontal asymptote is going to be on the x-axis because this is the only place where the y value is going to be 0. So we would say this is my horizontal asymptote and it's at y equals 0. All right? So now the last one, the last rule says that if the highest exponent in the numerator is equal to the highest exponent in the denominator, then the horizontal asymptote is going to be the coefficient of the top exponent, the coefficient of the highest term in the top over the coefficient of the highest term in the bottom. So here's what I mean by that. I'm going to make this 7 over 2. So what happens when we compare the exponents this time? So top exponent compared to the bottom exponent. In this case, the highest top exponent is 3 and the highest bottom exponent is 2. So they're equal. So if they're equal, that means the answer is going to be whatever the coefficient is. So we're going to say the coefficient of the top over the coefficient of the bottom. And if I break this breaks down to 3.5. So here, I'm going to go and say my horizontal asymptote is going to be y equals 3.5. So 1, 2, 3, that's 4. So I'm going to put a dot at 3.5, and then I'm going to draw a line through that and say y equals 3.5, and that is my horizontal asymptote. Okay? And those are the 3 rules. You can just keep referring back to these rules if you need to, so that you can answer these questions about asymptotes. I do it too. I refer back to them as well, because I sometimes forget them as well. All right, so let's go and do some problems. So let's do this first problem here. It says, given a rational function, this is my function, give the vertical asymptote. So if I'm going to find the vertical asymptote, from my definition, it says to get the VA, I need to set the denominator equal to 0. Set it equal to 0. So what's going to make my denominator equal 0? Well, in order to solve this, there's a couple of ways. You can use the quadratic formula, or you can use the X box. So I'm going to go with the X box, which we've used in class. So this is X plus 4 and X minus 3. If you need to look at the X box again, then go back and look at that so you can figure out how I factor this. Is in the video from last week, I think, or maybe the week before last. And then if you can't find it, I'm always available for tutoring to help you. So X plus 4, we're going to take each one of these factors and set them equal to 0. So we can find out what's going to make my denominator equal 0, and these are also going to be my vertical asymptotes. So x equals -4, and this is why we don't want 0 in our denominator, because these would make our graph not have a solution at that spot. So here we get our vertical asymptotes are at x equals -4 and x equals 3. These are making our denominators undefined. So here I'm going to go ahead and identify them on my graph. And so I'm going to put 1 here, so who's ever reading my graph knows that I'm going by ones on my scales. So I'm going to go to -4 on the x-axis. 1, 2, 3, 4. That's -4. And then I'm going to go ahead and draw my vertical asymptote through there and say this is my vertical asymptote at x equals -4. And then I'm going to do the same thing with 3. So 1, 2, 3. And then here, I'm going to go ahead and put my vertical asymptote on there. And it's going to be vertical asymptote at x equals 3. All right? So now we need to look for our horizontal asymptote. There are 3 rules. So we just need to compare the numerators. So the highest compare the numerator and the denominator. The top exponent and the highest bottom exponent is what we need to compare. So the highest top exponent is 2 and the highest bottom exponent is 2 as well. So they equal. So if they equal, that's telling me that my horizontal asymptote is going to be whatever this coefficient in front of these numbers are. So it's going to be 1 over 1, which equals 1. So that's telling me I have a horizontal asymptote at y equals 1. So I'm going to go to 1 right here on the y-axis. And then I'm going to go and draw my horizontal line through there. And here we have y equals 1, and that's my horizontal asymptote. All right? So now, in order to get we're not going to worry about the x-intercept. I'm going to show you how to use decimals to get that. But the y-intercept, we can use some algebra for. So I'm going to go here and show you how to do your y-intercept. So all you have to do, to get your y-intercept, all you have to do is take make x equal 0. Because in order to get a y-intercept, equals is where x equals 0. And you can get it from the graph too, but I'm going to show you how to do it algebraically. So I'm going to take this function and I'm going to say x squared over x squared plus 1x minus 12. That's minus 12, right? Yeah. And everywhere, I'm going to say everywhere there's an x, I'm going to put 0 in. Because in order to get a y-intercept, the x value has to be 0. So I'm going to say f of 0 equals 0 squared over 0 squared plus 0 minus 12. And you can put 1 there if you feel that you need to do it. So we get 0 over negative 12, which that means my y-intercept is going to be at 0. So my y-intercept is at 0. Now the rest of this, we know there's not an oblique asymptote because the highest exponent in the numerator is equal to the highest exponent in the denominator. So we know there are none. There are no horizontal asymptotes, oblique asymptotes. And the wholes, I don't have a factor. If I factor the bottom down, it's not gonna, in other words, when I factor this, none of the factors will go away. So I don't have a matching factor in the top, so I don't have any holes in this graph either. So only things left for me to do is find a domain, and I need to graph this function. So I'm going to use decimals to help me out from there. So guys, watch this. So I don't want the scientific calculator, I actually want the decimal graphing calculator. And you can always go to the PDF that I gave you as well to help you. So here, I'm going to use my little keyboard down here. I was looking for the fraction key on here, but they don't have one. So I'm going to say x squared divided by, and then x squared plus x minus 12. All right. So if you notice, you see those asymptotes on here, guys? Look, we got the asymptote at -4. We got the asymptote, well, I'm going to show you. So you see this side right here is coming all the way up, and then I'm going to shrink it down. And how it's getting really close to 4, but never crosses over 4. So I'm going to show you how you put this on your graph. So on this side of the graph, you're going to get really close to that asymptote, but don't touch it. And the same thing happens to this side. Get really close to that asymptote, but don't touch it. Don't cross over it at the bottom, and don't cross over it on the sides. That's what an asymptote does. It gets really close, but does not touch those points. And right here, where our intercept is at, where our y-intercept is at, then we have a little loop, and there's another asymptote right here. It gets really close, but not going to touch. So I'm going to draw where my 0, 0 is at. I'm going to get really close to my asymptotes, but I'm not going to touch them. And you're done. So now let's go and see, do we have any x-intercepts? Well, it looks like from my graph that this graph actually does not touch the x-axis. We know it's not going to touch here because it can't cross over this line. So this part is not going to touch. And right here, if you look, it's not touching the x-axis as well. So we can confidently say that there are no x-intercepts. So my x-intercept is none. And my y-intercept is 0. And then now we're going to do our domain. It looks like our domain is going to be from -infinity, the x-axis, the x values from -infinity until this asymptote right here, which is at -4. And then we're going to say we're going to pick up a union. We have our domain is in between 4 -4 and 3, and then we pick up the union again, jump over this asymptote, and so we tell people to go from 3, and then this x value goes on forever to positive infinity. And notice that I put parentheses. I put parentheses around the -4 and the -4 and the 3 and the 3 because they're not included in the domain because they're asymptotes. That means the graph can get really, really close to it, but it can't cross over that point. It gets really, really close, but it can't cross over that line that's there. That's what an asymptote means. So these points are not included. So we can go all the way up to them, but not touch it. So that would be my set of x values. All right. And then our range would be from -infinity to 1, and then pick up at a union from 1 to positive infinity. And we're not going to focus too much on the range with these. So I want you to go and try these problems, try this next problem, and then when you come to class, we'll talk and we'll do some more practice problems. Bye.